Okay, so anyway, we're going to look at an example problem here from a couple classes ago. Remember, we had a house. We're laying out the job. We had a theodolite or theodolist sitting at a reference point with a reference line. And for each corner, we located that corner by defining a distance from the location of the theodolite. That's our distance. And an angle from our reference line. So let's do point A here together. For point A, this side of the triangle is going to be how long? 20 feet. This side is going to be 40 feet. So my distance for point A will be the square root of 20 squared plus 40 squared. Otherwise known as 44.72 feet. That's our distance. Our angle is an inverse tangent of 20 over 40. Otherwise known as 26.57 degrees. Look familiar? So for each one of the corners, find the distance and the angle from the reference point and reference line. 90.24 feet. Perfect. The angle is going to be the inverse tangent of 20 over 88, which is going to give us an angle of what? 12.81 degrees. How many of you got those two answers for point B? Nobody? Okay. Anybody have any questions on where they came from? Okay. Point C, distance, is going to be the square root of 52 squared plus 88 squared, right? Where did the 52 come from? 20 plus 32, and the 88, of course, is from before. What'd you get? 102.22 feet. The angle is the inverse tangent of 52 over 88, which gives us 30.58 degrees. How many of you had those two numbers? You look confused, Mike.
Nope.
You're okay? Do you see how to do it when I'm doing it?
I didn't get a problem.
Oh, gotcha. Does it make more sense now? Okay. That's what matters, as long as it makes sense now. Point D, the distance is the square root of 52 squared plus, not 52 squared anymore, is it? It's 40 squared plus 88 squared, right? No, other way around. It's 52 and 40. There we go. Thank you. Which gives us what? 65 point what? 60 or 61? 61. Okay, we'll go 61. The angle then, of course, is the inverse tangent of 52 over 40, which gives us what? 52.43 degrees. What do you think? Good stuff? Any questions? Okay, so while you're working on this quiz, we're going to do a little bit of review. This quiz, actually, you're going to get to take home with you and bring back tomorrow, just so you know. I'm going to pass out something for you quick here so we can review. So on the paper I just handed out to you, we're going to talk about some things we've talked about before, but it's been a while, so I want to make sure we review it a little bit. Coterminal, do you guys remember what that means? More specifically, simplest coterminal means it's between 0 degrees and 360 degrees. So if I give you an angle is like 415 degrees, what that means is on the unit circle, it has wrapped around, once is 360 degrees. It's gone how far past 360? 55 degrees, right? How'd you get that 55 degrees? You subtracted 360. So the simplest coterminal angle for that is 55 degrees. Now we could have something like 920 degrees. To find its coterminal angle, I'd subtract 360, only to realize that it's still bigger than 360 degrees. So what would I do? Subtract 360 again. 200 degrees is the simplest coterminal angle. You have to keep subtracting 360 until you get between 0 and 360. No, you don't have no 2 or anything to say how many times it circled. It's just that is the angle. That is the position it stopped at. It's a measure of position and not rotation anymore. How about reference angle? We talked about this one quite a bit as well. What's that? Do you guys all understand how to do the first 3? Okay. Reference angle had to do with this. If I have a 30-degree angle here, its sine is 0.5. But there was another spot where there was a sine of 0.5. Over here, it also had to be 30 degrees above the horizontal diameter. That angle from the horizontal diameter is the reference angle. This angle has a 30-degree reference angle. Well, what angle is it? It's actually 150 degrees, but its reference angle is 30 degrees. It's the reference angle that determines the value of the sine and the cosine and everything else. The 150 degrees, that may show you whether it's going to be a positive or negative, but the actual value of the sine or cosine will be the same. Where else would we have 30-degree reference angles? Well, down here and over here. So this would be 210 degrees is 180 plus the 30. This would be 330 degrees, 360 minus the 30. So when I'm asking you for the reference angle of an angle, I'm asking you what is its angle to the horizontal axis. For example, if I give you 110 degrees, well, 110 degrees is somewhere in here, right? It's past 90. Well, the closest horizontal axis, or horizontal diameter, is right here. This would be its reference angle. What would that be? 70 degrees. It's 180 minus the 110, right?
70 is the reference angle of 110.
For the 110. You got it. Because that's the distance from 110 to the next horizontal diameter. Of course, if I give you an angle of 43 degrees, what's its reference angle? 43 degrees. Just right back. It's closer to go back to 0 than it is to 180. Does that make sense? To 0. To get the quickest way to get to that horizontal diameter. Remember, that horizontal diameter is a reference diameter. The smallest angle back to that reference diameter. So let's say I give you an angle of 213 degrees. 213 is over here, closer to 180. So we're going to subtract 180 from that to get 33 degrees. This is 33 degrees here. This is my reference angle. Does that make any sense? Okay. Possibly. Okay, so yeah, I kind of came pretty close to some of those examples. It shouldn't be too hard for you. I'm going to trust that you guys remember how to do the cosine and the sine of angles and the tangent. The secant, you might have to do a little review. So this one I'm going to have you take home and bring back in tomorrow as well. What's that? You messed up? Of course, the good news is there is no homework for tomorrow. The bad news is these 2 quizzes are due when you get here tomorrow.